The mean value theorem is this right here. Where does the average rate of change over an interval? So average rate of change is a fancy word for slope. It's just slope. So slope over an interval. So wherever the interval starts, wherever the interval finishes, how much did I change? Okay. Once you got that, you're going to set it equal to the instantaneous rate of change at a point. That's a complicated way of saying the derivative at a point. Okay. The derivative at a point. So you guys have done this all the last 2 chapters. So if I give you a function, if I say f of x equals whatever it equals, I don't know, let me make up something, 2x squared plus 4x minus 2. Instantaneous rate of change is like saying, okay, find the derivative and tell me what the derivative is at 3. You'd find the derivative and then plug in 3, right? That's instantaneous rate of change. Okay, you've been doing it since you learned about derivatives. So it's nothing new. Average rate of change, we really haven't talked about, but it's really easy. It's rise of a run. Okay, what's the rise from this point to this point? What's the rise? What's the run? Reduce it, that kind of thing. So where are they equal? So that's the 2 things we have to find. We have to find the average rate of change from the beginning of the interval to the end of the interval. And then we have to find the derivative, okay, at a certain point. Okay? Okay, so what is it? That's how to find it. That's kind of like how to do it, but what does it mean? What does the interval mean value theorem say? Well, let's say we go from red dot to red dot. Or sorry, blue dot to blue dot. Blue dot to blue dot, right? The blue dot, the left blue dot is our beginning of our interval. The other blue dot is the end of our interval. The average rate of change is what's the rise over run of that green line? How would I find the rise over run of the green line? What would I need to do rise over run? How would I find the slope of that green line? How do I find slope?
Rise over run.
Okay. You can count, but look at mine. The y values, it's 4 point something, right? So it might be easier to use the formula. You remember the formula?
No.
Oh, it's the point.
Ah.
So the formula, wait, let me not use regular points. Let me use x1, y1, right?
Yes.
And then this is x2, y2.
Isn't it like y2 minus
So the rise refers to the y's. The y's are the rise because that's the y-axis. So we go y2 minus y1. The run refers to the x's, right? So you guys have been doing that for a while. Okay? That's how to find slope of the green line. Now what the mean value theorem will say is, where do I have the same slope? In between blue dot and blue dot. So in between blue dot. So from this blue dot to this blue dot, where would I have the same exact slope? Where would I have the same exact derivative? Right? So how about like right here?
Okay.
Would the derivative at that dot be the same shape? Would it be the same path? Would it have the same derivative as the green line?
Realistically, probably
No, because that's the derivative there, right? Okay. How about over here?
no.
Not closer, right? But not,
A bit. Call it closer.
right? So over here, it's positive. Over here, it's negative. So probably somewhere in between, right?
It crossed the line.
Probably maybe somewhere like that,
Whoa.
right? 2-ish. At about 2, they would have the same slope, right? That's the mean value theorem. It'll tell you where they have the same slope. Okay? So what's that? Yeah, that's the thing. We're not getting graphs. Yeah, we're not getting graphs.
Once.
And sometimes It's better if we don't get graphs because I could say like around 2, it's going to have the same slope, but that's not the exact answer, right? So graphs sometimes help us visualize it, but they're not the best for actually getting the answer, the right answer, the best answer. Okay? So mean value theorem just says, so what the mean value theorem says is, if I have a slope, let's say this slope is -0.5. I have no idea what it is, but let's say it's -0.5. What the mean value theorem says is, somewhere along the path, at least once, I will have the same slope.
Oh, okay.
Think of this. I'll give you guys an actual application of this. Okay, so let's say I'm going down the highway. Okay, I'm going down the highway let's say from Fresno to the next town over, let's say Selma. Okay, from Fresno to Selma on 99. Let's say I started and finished. So let's say the distance from Fresno, let's keep it even. Let's say the distance from Fresno to Selma is 10 miles. Okay? So how much did I go? I went 10 miles, right? That's my run. Okay? How fast did I go, right? Wait, no, that would be 10. Sorry, 10 goes on top. How fast did I go? Well, how fast did I get there time-wise? Not that's a rate. I don't want my rate. I want a 26 minutes.
You're going slow.
Okay. So you want to find your speed, right? Your average speed. You just divide them, right? So it would be whatever it is. Whatever it is.
Wait, Taylor, how fast are you going?
Let's see.
And from where?
For 10 miles? You said we're going on the highway.
Oh,
Okay.
never mind.
0, 3, 8. Was that 5? Miles per minute. Per minute, right? Because that's minutes. All right? If you want to change it to miles per hour, what would I have to do? Multiply by 60. So that was 23 miles an hour. Right? Okay. All right, so what that tells me is that my average speed, my average miles per hour was about 23 miles an hour. What the mean value theorem says is, somewhere between your trips, somewhere on your trip, in between, you had to have been going 23 miles an hour, even if it was for an instant. You had to have been going at least 23 miles an hour once. Maybe twice, maybe 3 times, you know. So what is that? Where's the application? Well, most of you guys are drivers, right? Have your license or a permit or something? Okay. All right, well, okay. All right, so have you ever heard of the thing called a speed trap?
Yes.
There's different kinds of speed trap. One of them is where you're going 50 miles an hour because it says 50 miles an hour, and then all of a sudden it's like 25 miles an hour, right?
Yes.
So like that's one type of speed trap. The other type of speed trap is mean value theorem. So what they'll do is if I time you from point A to point B, and I can figure out that you were going, on the highway it's 65 miles an hour, right? So if your average, just like the way I did it right there, right?
Yep.
If my average rate of speed or average rate was over 65, right? Somewhere along there, you had to have been going over 65. Okay? So they don't need to actually see you go over 65. They know that there's no way for you to have made it to from point A to point B that fast without breaking the law at least once. So they don't even need to see you. Okay? That is another type of speed trap. So they use a little bit of calculus to do that. Okay? So that's the application of it. That's the most common application there is speed trap. There is no way for you to average over 65 miles an hour from point A to point B. You had to have been going over 65 at least somewhere between there. I don't have to see you. Mean value theorem says you had to.
Challenge that
Right?
before they pull out calculus.
I'm
Right.
actually like leaving.
Right?
I'm like, I'm done. I did this.
Right? Yeah, exactly. Calculus would not be on your side in that case. Yeah. You didn't see me go break the speed limit. Yeah, but I know you did. I know you did, right? So whatever your average rate of speed is, okay? So they don't need to actually catch you with the gun, with the speed gun. They can just do calculus to figure out you were breaking the law. So just be careful, okay?
I don't know, I think it's speed gun so more convenient.
Okay, so conditions. When can we use it? When can we not use it? Well, it has to be continuous and has to be differentiable. Okay? Has to be continuous and has to be differentiable. If it's not continuous or it's not differentiable somewhere along there, we can't use the mean value theorem. Okay? All right, so let's take a look. So the first one, I give you a graph. But most of the time, like I said, they won't give you one. Okay? So we got to figure it out without the help of a graph, okay? So apply the mean value theorem to the function on the indicated interval. So the interval is from -1 to +1. It's not a very big interval. So from -1, that's the starting spot. From +1, that's the ending spot.
Oh my. What an interesting slope.
That's the average rate of change right there, if I were to find the slope of that green line.
Oh,
Okay?
it's like barely under 1.
In each case, make sure the hypothesis is true. Then find all the values of C. So where in between each blue dot, so where here, would I have exactly the same slope? That's what it's asking. Where would I have exactly the same slope on the blue highlighted part as the green? Okay? So the first thing is we got to be able to make sure we can use the mean value theorem. So f of x, is there any continuity issues or is there any differentiability issues? In other words, where I can't plug in this number, I would get undefined. Or I can't find the derivative at this point because it would be undefined. No. No, it's just a regular function. Okay? So first thing we're going to do is find the derivative.
Oh, darn.
Okay? Well, instead of using the, I could easily use, because it's multiplication, right? I could easily use the product rule, but instead of using that, let me just distribute. So I get x cubed minus x squared minus 2x. Oops, that's not the derivative, that's the original. So the derivative would be 3x squared minus 2x minus 2.
So that is a function.
Okay. That is the green part there. Okay, so that's part of our answer, that's half. The other half is the average rate of change. What is the average rate of change from beginning of the interval to the end of the interval? So to do that, we're going to use our slope formula. y2 minus y1 over x2 minus x1. Well, I already know my x's, -1 and +1. x1 is -1, x2 is +1. They told me. So how do I find the y values at those points?
Oh, can we plug in the x values?
To where?
The base function?
Yes, exactly. So f of -1, so we would get -1 cubed minus -1 squared minus 2 times -1. So we would get -1 minus 1 plus 2, right? So is that 0? Yeah. So 0. That goes right above the -1. And then we do the same thing when we plug in +1. 1 cubed minus 1 squared minus 2 times 1. So we get 1
minus 2.
Minus 1, minus 2. Yeah, negative 2. So the average rate of change is negative 2 over positive 2, which is negative 1.
Plus 1.
That's my other answer, or my other part. So now you're going to set the green equal to the yellow and solve. Okay. So the green was 3x minus 2x minus 2, and the yellow was negative 1. Solve for x. It's a trinomial. So I'm going to add 1 to both sides. So I get 3x squared minus 2x minus 1 equals 0.
No. What?
So I get negative 3 over negative 2. So it has to be 3 and 1, negative 3 and negative 1. So minus 3 plus 1. But then I have to divide by a. And if I can't, it moves to the top. So I get x minus 1 and 3x plus 1. Okay. I get two answers. I get positive 1 and negative 1/3.
Let's see.
Here's the answer. Or here's the question that will give you the answer. Are they both the answer? Is one of them the answer? Or is none of them the answer? How do we know?
See if it's on the interval.
There you go. Yep, see if it's inside the interval. Is positive 1 inside the interval? Yeah, because it's closed. It's closed, so it works. Is negative 1/3 inside the interval?
Yeah.
Yep, so they both work. So what are the values of C? C is positive 1. C is negative 1/3.
This is not fun.
Okay.
Oh no.
Find the derivative. Find the average rate of change. Set them equal to each other. That's our job. That's what we're going to do with mean value theorem. It's pretty straightforward. Find the derivative. Find the average rate of change. Slope. Set them equal to each other. Okay. All right, so number 2. Apply the mean value theorem to the function on the indicated interval. So the interval is from negative 3 to positive 5. In each case, make sure the hypothesis is true. Make sure that we can use the mean value theorem or it doesn't apply here. Then find all values of C inside the interval guaranteed by the mean value theorem. Okay. So where do we start? What was our first step when we started number 1? Even before that.
I thought it was find the x value that can make it undefined.
Yeah, continuity. Is there any continuity issues here? Is there any x value I can throw in there that would make it discontinuous?
X equals 1.
Yeah, right? Look at the bottom.
Then it doesn't work anymore.
Oh shoot. Big.
It does not.
Not continuous at x equals 1, right? It's going to be an asymptote at x equals 1. So it's not continuous. It's only a problem if it's in the interval. Is 1 in the interval?
Ooh.
So we can't do it. So we say the mean value theorem does not
You are so weak.
apply because f of x is not continuous at x equals 1. So we'd get an answer. Here's the problem. You'd get an answer if you did the steps, find the derivative, find the average rate of change, get an answer. You'd get an answer if you actually continued going. but the answer would be meaningless. It wouldn't be the right answer because it violates the first condition. Right? It violates the first condition. Okay. All right. Will that happen? Rarely, but it could. Doesn't happen a lot, but it could. Okay, let's look at number 3.
There's something fishy going on.
So when you're doing mean value theorem, when you're doing a mean value theorem question, always in your head think, are there any continuity issues? When you look at f of x, are there going to be any continuity issues?
No.
Or if I find the derivative, is the derivative going to have any continuity issues, right?
Why are we adding this?
Okay. So this one's just a cubic. It doesn't look like there's going to be any continuity issues for f of x. Okay. So there doesn't look like there's going to be any numbers I can plug in for f of x where I will get undefined. Is graph below? They didn't give you the graph this time. Okay. Plot a line segment connecting the points. Okay, so that part, don't worry about.
Okay, thank God.
So this part, yeah, we don't have to make the graph. Okay.
You make students last year do this.
Afterwards, determine all values of c which just satisfy the conclusion of the mean value theorem. In the closed interval from -6 to -3. So we already said there's not going to be continuity issues because any number I plug into f of x, I'll get an answer. Positive, negative, fraction, decimal. Okay? There's not going to be any asymptotes or holes or anything like that. All right, so once we do that, once that's out of the way, what was our first step?
Derivative.
Derivative. Now we can do derivative. So the derivative is 3x squared plus 14x plus 4, right?
Yep.
So that's half of what we need.
That's not.
Now what's the other thing that I need?
Your slope. Your
Slope. Yep, rise over run. So it needs to go from -6 to -3. So -3 minus -6. That goes on the bottom. So on the bottom, I'm going to get 3. Now I need to know what are the y values for -6 and -3. So this is where I got to plug in -6 and -3. So f of -6, -6 cubed plus 7, -6 squared plus -6 minus 17. So -6 times itself 3 times, I believe is -216.
Yes.
Okay. -6 squared is 36 times 7. 252. Yep. Positive 252. Minus 24 minus 17.
Darn.
So 216, -216 plus 252, 36. Minus 24 minus 17, that's going to be 12. Minus 17 is -5.
All right, -3. -27.
Okay. -3. So -3 squared is -27. -3 cubed is -27. -3 squared is 9 times 7 is 63. Minus 12 minus 17.
All right. 39.
So that's going to be 36 minus 12 minus 17.
7.
Should be 24, yep, positive 7.
Oh my. With a flat 4. Oh my.
Yep. So 7 minus 5 is 2. So we get positive 2/3. There's our other part of our next step. So the next thing we're going to do is set the green equal to the yellow.
I thought it was minus 5.
Yeah.
Wouldn't it
Yeah,
be
always.
plus?
Oh, minus 5. Yep. Yep, you're right. So it'd be 12. So that equals 4. Okay. All right. So last step. Set them equal to each other.
Equals 4.
3x squared plus 14x plus 4 equals 4.
Hey, wait a minute.
Subtract 4 from both sides. It's going to be a binomial. So we get 3x squared plus 14x equals 0. If it's a binomial, just x is the GCF, so I get 3x plus 14. So I'm going to get 2 answers again. X equals 0.
Oh, X is going to be something weird like the...
You're going to subtract 14 from both sides. Negative 14 over 3, yep. Leave it as negative 14 over 3. Don't change it to a decimal or leave it as a fraction like that. Now, what number is that around? Negative 14/3.
Like minus 5.
It's just a little bit, yeah. So it's between negative 4 and negative 5, closer to negative 5. Okay. Why do I ask that question? Because the next step is,
What's in it? What's in the interval?
yep, is it in the interval? Are both of them within the interval? Negative 6 and negative 3? Which one's not in the interval? 0.
X is
So
not-
0, yep. These are multiple choice questions waiting to happen. Why? Because they always do this. They'll give you this problem. A will be both of them. A will be 0 and negative 14/3. B will be just 0. C will be negative 14/3. D will be none. So you got to know, is it both? Is it one? Is it none? Just like you guys did, right? So 0 doesn't work. 0 does not work. Not within the interval. Not within the interval. Okay? All right, so I want you to do number 4. If you haven't already started it, start number 4.
8 minus 2 plus 8 plus 16.
Seven? 47?
Guys, don't you love 47?
No.
I like getting on 40. I like 47. 47.
I'm struggling on the simple math right now.
I do 2. Pretty easy, so
You didn't do 2 yet? It's 2 is
Okay.
silent.
So eventually, when you get there, you get down to, so you have the first derivative is 3x squared minus 16x plus 4. The derivative, or the slope, average rate of change is -1. You set them equal to each other. It's a quadratic, so you're going to get 2 answers. Eventually, you get positive 5 and negative 1/3. Okay?
Negative. Isn't it negative 15 and negative 1?
Yeah. It should be -1.
Negative 15, positive 1?
No, -1.
because they add to minus 16.
Oh, wait. Yeah. You're right. This is going to be -1.
Oh, it's
So that'll
still a no.
be
It's still no.
a -1. So that would be a -1 again, which would lead to a positive 1/3, right?
And it's still not.
Yeah, it's still not in the interval, but it is important.
Darn. I was gonna ask
Okay.
For help?
for help.
I did it on my own.
Good
I
for
told
you.
you.
All right.
I'm smart when I'm in class.
All right.
How true is that statement?
So that's the mean value theorem. So the last page isn't so much mean value theorem, it's just a preview of what we're gonna see. And since we have some time, there's 3 problems on there. Something that you're gonna have to, we're definitely gonna do this chapter. We haven't looked at any graphs. We haven't done anything with graphs in a long time. So the next thing that we're gonna be getting into is graphs of derivatives. What do they look like? How are they created, right? The only graphs of derivatives that we've done are when we did sine and cosine. That's the only graphs that we've done.
Well, luckily.
Okay. So Roman numeral 1, 2, and 3 are the original graphs. So those are the originals. So those are all the f of x's. A, B, and C are f primes. Which one goes with which? So when we're looking at an original, there's a couple different ways to do this. There's a couple different ways to do it. There's not just one way. It's what way works for you best. So look at number 1. Number 1 is a parabola.
Yes.
Parabolas go with which power derivative, which power function or equation they go with? 2, right? It's quadratic, right? When we find a derivative, what happens?
It becomes there's no more.
It goes down, right? It goes every time. When we find derivatives, it goes down in power. So what if I had a squared and I took a derivative, I would have just x, right? And if it's x to the first power, what is that always going to look like?
A line.
A line. So you know that 1 and c go together. That's one way to do it. Can't always do that because sometimes like number 11, no, or sorry, Roman numeral 2, that is a trig, right? Trig function, okay? And you might not remember, is that a quadratic? Is that a cubic? All those things. So there's another way to do it, okay? The other way to do it is to look for key features of the graph. Where on this graph, I don't want to say where, but because there's no x values or y values, but is this graph ever going to have a derivative of 0?
No. Actually,
Is this graph ever going to have a derivative of 0?
if x is like pi over 2 or something.
Wait, for which one?
This graph right here. Is this graph ever going to have a derivative of 0? What do I mean by derivative of 0?
It's a constant.
Yeah, where this tangent line is a straight line like that. Yeah, where is it going to have it at? At the very, where it switches from decreasing. In other words, when I ask that question, I'm just asking, is there a switch from decreasing to increasing or vice versa? Yeah, there is one right here. So that's going to have a derivative of 0. So that means on the derivative graph, at the same y value, you should have something touch the x-axis. So at that y value, again, it's hard because they don't have any y values, but somewhere along here, you should have a derivative that crosses the x-axis. Right? Or it goes, this guy goes from decreasing to increasing, right? So it should have, before this dot, it should be below the x-axis, because that's negative, decreasing, right? Negative derivatives, to increasing, positive derivatives, right? So at this y value, it should change from negative to positive. That one does as well. Okay? There's different ways to do that. Easiest, like I said, is just to, what type of function is it? What would its derivative be? Like Roman numeral 2, what function does that look like? It looks like sine. What's the derivative of sine?
Cosine.
So just look for cosine, right? That's kind of the easiest way to do it.
I mean, the rest of them are all fine. This one specifically hand drawn.
So there's only one left, right? 3 and 1. So obviously by elimination, we know that 3 and a have to go together. But what type of function, let's picture that there wasn't just one left. What type of function is that?
That's a
Cubic, right? It's a cubic, right? It's x to the third power. If we were to find the derivative of this, how many powers would we have left? Makes a quadratic, right? So we're looking for a quadratic answer.
I see.
Okay, that's the other way. So that's why quadratic's derivative is linear. You guys know that. You guys knew that. That sine's derivative is cosine, and a cubic's derivative is quadratic. Okay, so it's not part of this lesson, but it is something we're going to see coming up here pretty soon. So I wanted to kind of show it to you before you saw it, preview it. Okay,
So if we had a line and we had to match like C does.
that's a good question.
If we get,
Yeah.
if we, so would our derivative just be the line with the constant?
Exactly. So yeah, it's a great question. Let me stop.